Okay, so today we're going to take some notes on exponents and same base equations. This should be a review from Math 1. It's been a while, but we're going to kind of go over these. So starting out pretty simple, 2x cubed times 4x. Remember, on a problem like this, you multiply 2 and 4 to get 8. And then we have 3 x's here and 1 x here. So essentially you add your exponents and it's 8x to the 4th. Because remember, what we did in Math 1, this was 2 times x times x times x times 4 times x. And we can see that there's 4 x's there when we multiply it out. On number 2, we have 2x squared all to the 3rd power. So there's a couple different ways you can do this one. Remember, this 3rd power means you have this 3 times. 2x squared times 2x squared times 2x squared. So 2 times 2 times 2, we get 8. X squared, x squared, x squared. So I have 2 x's here, 2 more here, 2 more here. And it becomes 8x to the 6th. Another way to do this same problem is we could have distributed this exponent essentially when it's outside of our parentheses. So it becomes 2 to the 3rd x to the 6th when we distribute, because on this 2, there's an exponent of a 1 that we don't write. Number 3 is 4a to the 4th b to the 3rd times 3a to the 4th b to the 3rd, all divided by 2a to the 3rd b to the 4th. So when you're doing all of these problems, you can kind of do them in different orders or different ways how I showed you here. If you do it slightly different, that's okay. What I'm going to do here on the top, 4 times 3 is 12 in my numerator. I have a to the 4th times a to the 4th, so that becomes a to the 8th, b to the 6th, 3 b's here and 3 more here, all divided by 2a to the 3rd b to the 4th. As a reminder, what this looks like written out, and I'm not gonna do this on all of them. 12 is equivalent to 2 times 6. A to the 8th is 8 a's. And then 6 b's. And then in our denominator we have 2 times 3 a's and 4 b's. So by writing 12 as 2 times 6, I did that so I can see that my 2's cross out. Remember, when they cross out, they become a big 1. 3 of my a's cross out, and then 4 of my b's cross out. And you can see that we are left in our numerator. Nothing's left in our denominator. It was just a big 1, so we don't write it. So 6a to the 5th b squared. And again, this was just to remind you where it comes from. Essentially what we did here is, on a division problem, you get to subtract your exponents. Number 4 is 4a to the negative 2 times 3a to the negative 3. None of your answers should contain negative exponents. So, reminder, negative exponents are the reciprocal. This negative 2 is only with the a, not with the 4. So this is equivalent to 4 over a squared Again, the negative 2 takes that to the bottom and the exponent becomes positive, times 3 over a cubed. Exponent of negative 3 makes the exponent 3 in the denominator. So when I multiply straight across, I get 12 over a to the 5th. Number 5 is 4x to the negative 4th all to the negative 3rd power. So I'm personally, so again, you can either distribute, and I'll show you both ways here. You can distribute or you can simplify inside and then do your exponent outside. So if I simplify inside first, I have 4 over x to the 4th to the negative 3rd. What the negative means is I flip this, and then third means I do it 3 times. So it's x to the 4th over 4 times x to the 4th over 4 times x to the 4th over 4. Again, negative, flip your fraction over. 3rd power, write it 3 times. So this becomes x to the 12th over 64. Oops, that should be a 4. The other way to do this same problem, I was saying, is we could distribute this exponent. So it gets distributed to the 4, and because that 4 has an exponent of 1, so it's 4 to the negative 3rd x to the positive 12th. Negative times negative becomes positive, so this is x to the 12th over 4 to the 3rd, because the negative on that exponent takes it to our denominator, and you see that we get the same thing either way. Number 6 is 2x over 2x to the negative 3rd. Personally, what I'm going to do right here is I see a 2 over 2 and I can cross them out. You don't have to do that first, but neither of those have parentheses or exponents, so I can. And then this x to the negative 3rd is in my denominator, so it moves it to the numerator. So it becomes x times x to the 3rd, which gives us x to the 4th. I had 1x in my numerator, and I moved 3 more up there. I end up with 4. Number 7 is a to the negative 3rd b squared times 4a squared b squared. So the first thing I'm going to do is I'm going to move this negative exponent to my denominator, or I could add my exponents. Remember, on a multiplication problem, you're just adding your exponents. So if I just want to go and add my exponents, I have 4 for my coefficient. For my a's, I have an exponent of negative 3 and positive 2. So that becomes negative 1. For my b, I have an exponent of 2 and 2, so when I add those, I get b to the 4th. So 4a to the negative 1, b to the 4th. Well, we know we can't have a negative exponent, so that a goes into my denominator. And we don't usually write the exponent of 1. So it's 4b to the 4th over a. Number 8 is 2y x to the 0 all to the negative 4 power. So as a reminder, anything to the 0 power is 1. So x to the 0, that's just 1. So we're multiplying by a 1 there. We don't need it. So this is equivalent to 2y to the negative 4th. So again, you have your option. You can distribute the negative, or you can flip it and write it 4 times. You're going to get the same thing either way. It's going to be very similar to number 5 up here. So it's 2 to the negative 4th, y to the negative 4th. So it's 1 over 2 to the 4th, y to the 4th. 2 to the 4th, remember, is 2 times 2 times 2 times 2. So 1 over 16 y to the 4th power. Number 9 is 4x to the negative 4th, y to the negative 3rd, all divided by 3x to the negative 2nd, y to the negative 2nd. On a division problem, you can, remember, just subtract your exponents, as I was talking about back on number 3. But when you have all these negatives, it can get a little bit tricky, and you're more likely to make mistakes. If you're very careful, sure, go ahead and do it that way. Personally, I'm going to flip these so that they become positive exponents first. So my 4 and 3, my coefficients, nothing happens to those. This x to the negative 4th in my numerator goes to my denominator. The x to the negative 2nd in the denominator goes to my numerator. Remember, the exponents switch signs and become positive. And then same thing, the negative 3 is in my numerator for the y, and the negative 2 is in my denominator. So it ends up like that. Again, you can write it out the long way. You can subtract them. You can kind of ask yourself where they're more and how many more. So my 4 and my 3, those don't get to simplify at all. My x's, I have 2 x's on top and 4 on bottom. So I have 2 more x's and they're left in my denominator. So my denominator is going to be x squared. Again, if I subtract my exponents, 2 minus 4 would be negative 2 for my x's. So this would be like x to the 2 minus 4, x to the negative 2, which puts it in my denominator. I like to think of it as where do I have more and how many more. So if I wrote it out, I have 2 y's on top and 3 on bottom, so I have 1 more in my denominator. So it's 4 over 3x squared y. And again, if that kind of subtraction is confusing, it only takes a few seconds to write it out the long way and to make your big ones. I'm just showing you that there are several different ways to kind of approach these exponent problems. Number 10 is a to the negative 3rd, b to the negative 4th, all to the 4th, times 2a to the 3rd, b to the 3rd, all to the negative 1st power. So I'm going to distribute my exponents. So I have a to the negative 12th, b to the negative 16th, times 2 to the negative 1, a to the negative 3, b to the negative 3. Well, anything with a negative exponent flips it over. Since these are all negative in here, it becomes a 1 in my numerator. So 1 over a to the 12th, b to the 16th, times 1 over 2a to the 3rd, b to the 3rd. Remember, when you multiply fractions, you go straight across. Numerator times numerator, 1 times 1 is 1. Here, my only coefficient is the 2. A to the 12th times a to the 3rd. That's going to be a to the 15th, and they're all in my denominator, so we just add those exponents. And then b to the 16th and b to the 3rd, I get b to the 19th. So 1 over 2a to the 15th, b to the 19th. And here we're going to start with a few fractions. So 11 is u to the negative 4th v squared, all divided by 2u. And then this whole thing is to the negative 1 power. So again, you have options. You can distribute the negative 1 and then simplify, or you can simplify inside your parentheses and then worry about the exponent outside. I'm going to simplify inside my parentheses first on this problem. So my u to the negative 4th moves to my denominator. So my v squared stays up top. The 2 stays in the denominator. I had u in the denominator. Remember, that has an exponent of 1. And then 4 more come down, so now I have u to the 5th in my denominator. So again, 1 was down there. These 4 come down. That leaves 5. Now with this exponent of negative 1, that just means you flip the whole thing. So 2u to the 5th, all divided by v squared. Again, if we distribute it, all of these just become negative, and then you flip them. Number 12 is a to the negative 3rd, b to the negative 3rd, times 2b squared, all divided by 4a to the 4th, b to the negative 3rd. So, options again. You can simplify inside your numerator first, since I have b's here and b's here, or you could get rid of all of your negative exponents first by flipping everything that has a negative. So I'm just going to simplify my numerator, multiply these, and it becomes 2a to the negative 3rd, b to the negative 1st. Again, I had a negative 3 here and a 2 here on my b's, so I add them, over 4a to the 4th, b to the negative 3rd. Now anything with a negative exponent is going to flip, become the reciprocal. So nothing happens with my 2 and my 4 in front yet. If you want to simplify it first, go ahead. This a to the 4th stays in my denominator. This had a negative 3 on my a. It moves to my denominator. Both of these b's have a negative, so they both flip where they are. The b to the 3rd goes to the top, and the b to the negative 1 just becomes b in my denominator. If you want to write the 1, go ahead. And now we get to simplify. 2 over 4 becomes 1/2. My a's, I have 4 here and 3 more here. They're both in my denominator, so I just add them. A to the 7th. My b's, I have 3 on top and 1 on bottom, so I end up with b squared in my numerator. 3 minus 1 is 2. So b squared over 2a to the 7th. And last exponent problem on this side, and then we'll go to the same base equations. X squared times xy to the negative 2 over x to the negative 3, all to the negative 3rd power. Again, your preference. Do you want to distribute the negative 3? Or do you want to simplify inside your parentheses and then worry about outside? If I simplify inside first, x squared times x becomes x to the 3rd. This negative 3 on bottom moves to the top. so times another x to the third, and this negative 2 in my numerator for my y moves to the bottom, with the negative 3 still outside. So again, x squared times x became x to the third. This x to the negative 3 moves to the numerator, and this y to the negative 2 in my numerator moves to my denominator. So I have x to the 6th over y squared, this whole thing to the negative third power. If I distribute that, x to the negative 18th over y to the negative 6th. I don't need my parentheses anymore. They're both negative exponents. I flip them. Y to the 6th over x to the 18th. So that was our review part on exponents. Now I'm going to flip over and we're going to do a handful of problems on same base equations. So 4 to the power of n minus 2 is equal to 4 to the power of negative n. So on these problems, when the bases are the same, you essentially just get to get rid of them, and your exponents are equal to each other. So n minus 2 is equal to negative n. And you solve. Subtract n on both sides. Negative 2 equals negative 2n. So n equals 1. On 15, we have 5 to the power of 2k plus 3 equals 5 to the power of 4. As soon as you see that your bases are the same, just get rid of them. 2k plus 3 is equal to 4. 2k equals 1. So k equals 1/2. But they're not always going to be that simple. Again, that's how we started them back in Math 1. On 16, we have 5 to the power of negative 2a plus 1 is equal to 625. So when the bases are not the same, you have to make them the same. And typically we're going to change our larger number. So this 5 to the negative 2a plus 1 stays the same. And we ask ourselves, how can I rewrite 625 with a base of 5? So how many 5s do you have to multiply together to get 625? You can kind of multiply them out. You can guess and check. We know 5 squared is 25. Oops. 5 to the third is 125. 5 to the fourth, we get 625. So we can rewrite 625 as 5 to the fourth. Now my bases are the same. I can just get rid of them. Negative 2a plus 1 equals 4. Subtract 1 on both sides. Negative 2a equals 3. Divide by negative 2. And I get a equals negative 3 over 2. Seventeen is similar but a little bit trickier. It's 125 to the power of negative 2a plus 3 equals 25. So on this problem, we have to rewrite both bases. 25 and 125, and that's why I left my calculator here, they can both be written as with a base of 5. So 25, we all know, is just 5 squared. But 125 is 5 to the power of 3, 5 cubed. But it still has this other part of the exponent, 2a plus 3. So again, 125 becomes 5 cubed. 25 becomes 5 squared. This exponent still stayed there. Now, just like we reviewed on the exponent problems, when you have an exponent outside of your parentheses, you're distributing it. So this left side becomes 5 to the power of negative 6a plus 9, and the right side is just 5 squared. You don't cross out your 5s. Well, you could cross them out first and then multiply, but again, I just distributed my exponent. So this whole thing is negative 6a plus 9 as my exponent. My 5s get to go away. So negative 6a plus 9 equals 2. Subtract 9 on both sides. Negative 6a equals negative 7. Divide by negative 6. I get 7 over 6. There's 2 more. Number 18 here is 6 to the power of 3m plus 1 equals 1 over 6, 1/6. So, same idea. These have to have the same base. 1 over 6, just like we saw in our last, on the exponent reviews, that's just the same as 6 to the power of negative 1. Remember, 6 to the power of negative 1 just moves the 6 into my denominator. So I get 6 to the power of 3m plus 1 equals 6 to the power of negative 1. My 6's get to go away. 3m plus 1 equals negative 1. Subtract 1 on both sides. 3m equals negative 2. Divide by 3. M equals negative 2/3. And last one here, 19, is 64 to the power of negative 2x equals 1/4 to the power of 2x minus 1. So this one's trickier because I have to rewrite 64 and 1/4 both with the same exponent. So on this left side, I'm going to have something to the power of negative 2x. Again, when I rewrite 64, it'll be inside those parentheses. And then I'm going to have something over here to the power of 2x minus 1. So I have to ask myself, how can I rewrite 64 and 1/4 to the same, with the same base? So we know 1/4 is the same as 4 to the negative 1, just like we saw with the 1/6 over here. So we'd ask ourselves, can we rewrite 64 as 4 to some power? We're kind of asking ourselves, how many 4s, and it's kind of a question, how many 4s would I have to multiply together to get 64? And you may know it, you may use your calculator. 4 times 4 is 16. So if I add another 4, I get 64. So 64 is equivalent to 4 to the 3rd. So 64 and 1/4 I can rewrite as a base of 4. If I wanted to, I could also rewrite them as a base of 2. You just have larger numbers. So I wanted to go to the easier route, I felt. So 1/4 in this parentheses on the right is 4 to the negative 1. And over here, this 64 on the left is 4 to the 3rd. multiply my exponents. 4 to the power of negative 6 equals 4 to the power of negative 2x plus 2. And I can get rid of my 4's. They're the same base. So negative 6x equals negative 2x plus 2. Add 2x to both sides. Negative 4x equals 2. And then divide by negative 2, or sorry, by negative 4, and I get negative 1/2.